This question might be harder than it looks, and I'll be honest, it doesn't look easy. These simultaneous equations questions are tough because there's no common strategy to go about ones like this. We normally use substitution, but here, the substitution is going to get really messy unless we find some way to simplify the equations first. We use the structure of the equations to try and look for regularities or symmetries that are going to help. Probably as you're looking at this question, you've picked up on two things already. The first one being, well, there's an xy in both of these, so if we subtract the equations, then we're going to eliminate this part. The trouble with that is, when we eliminate it, and we've got x squared plus x minus y squared plus y equals 12, it's not actually simpler than either of the equations that we started with. It might still work, someone can prove me wrong in the comments, but there's another thing that you'll probably have already noticed about these two equations, which might be a better route to go down, which is noticing the first three terms in the first equation all have an x in them, and the three terms in the second equation all have a y in them. So what we could just start by doing is factorizing that out and see what happens. So we can go ahead and do that. So we factorize the first one to get x times 1 plus y plus x equals 9. And for the second one, it's y times 1 plus x plus y equals minus 3. And now you might have seen something. What's inside these two brackets is identical. And it's a good job we didn't add or subtract these two equations, because now we can divide one of the equations by the other one and eliminate this whole part, which makes it a ton easier. So we do this divided by this and this divided by this. The 1 plus y plus x and 1 plus x plus y, they're the same thing, they're going to cancel. So we're going to get x over y is equal to 9 divided by minus 3, which is also minus 3. So x equals minus 3y. Now, this is what we were looking for. Now we've got a simple equation that we can substitute back into either of our original equations. But I say either of the original equations, which one's going to be easier? If you said the second equation, good. Yes, exactly, because there's only one x part in the second equation. So we just need to substitute the minus 3y in the second equation. It's going to be much easier because there's fewer things to substitute. So we can go ahead and do that. We get y minus 3y squared plus y squared equals minus 3. Collect the like terms, y minus 2y squared equals minus 3. We can move that all onto the other side. So we'll get 2y squared minus y minus 3 equals 0. Now, not an easy factorization, but not impossible as well. We're looking for things that multiply to minus 6 and add to minus 1. So you can do minus 3 and 2. And that's how we're going to split the middle term. So we get 2y squared minus 3y plus 2y adds to minus y, of course. Minus 3 equals 0. And now we can factorize this nicely. So factor out the y from the first two terms to get 2y minus 3. And then we've just got plus 1 times 2y minus 3. Factor this out from these two parts to leave y plus 1. So we get y plus 1 times 2y minus 3 equals 0. And that gives us our two solutions. We're just going to write it up here. So y equals minus 1 or y equals 3 over 2. Of course, we're not done yet. We need to substitute that back to find our x values. So minus 3 times minus 1 will give us x equals 3 as one of our solution pairs. The other one, substituting 3 over 2, is going to give us x equals minus 9 over 2 as our other solution pair. Did you get the answer? And did you like this question? Let me know in the comments.